In this video, we're going to do a quick recap of the two main formulas that we've seen so far for the moles unit. So the most famous formula of all, the first one we started with, was simply to find the number of particles. And that was that the number of particles is equal to the number of moles times the Avogadro's number. And the other formula that we saw was that you could find the number of mass by taking your number of moles and multiplying that by the molar mass, which is big M. And then from these, you can derive other equations. So for example, let's say you had your mass and your molar mass, and you want to find your number of moles. Well, then what you could do is you could say that N is equal to your mass divided by your molar mass. So let's call this equation 2 here. This one's equation 1. And let's call this equation 2a. And you could also, not that you would always need to, but if you wanted to, let's say you had an unknown compound or unknown element and you want to find its molar mass because you couldn't go to the periodic table since you don't know what it is, you could just do that the molar mass big M is equal to the mass over little n, the number of moles. So depending on what you have, you need to choose one of these proper equations here. And so these could be derived by simple isolation of a variable, dividing both sides by big M, for example, or by little n. And that way you can get your missing variable. This one here, this equation, if you're looking for the number of moles instead, so let's say you had the number of particles and the Avogadro's number. For number of moles, you could do N is equal to big N over Na. There's no point in really finding the formula to find Na because you always know it. It's always 6.02 times 10 to the power of 23. So there's no point in really arranging it to do that. So that would be one of the equations you can derive from that main equation there. So generally, this equation 1, you're basically using it for number of particles of some sort that you're trying to find, or number of moles if you have the number of particles. If you, for equation 2, you're really using that if you want to find the mass in grams or the number of moles if you have the mass in grams. And you can connect the two, for example, right? So you can do, let's say you had the number of particles and you want to go to the mass in grams. What you would do first is you would go to the moles. Whoops, moles is little n. And then you would go to the mass. You can go from the number of particles to moles by dividing by Avogadro's number. And then you can go from moles to mass by multiplying by the molar mass. You could also go, if you want to go from mass to particles, you could go mass to moles first by dividing by molar mass, as you can see over here, and then moles to particles by multiplying by Na, as you can see over here. So you can combine these equations, and if you want to go to either one of the extremes, from one extreme to the other, you need to make sure that you first convert to moles, then convert to the other extreme. There is a trick I can show you to help you remember the formulas more effectively. You might have a trick of your own. I don't like showing this trick too often just because it takes away your understanding. I'm going to show it just sort of as a last resort in case you get nervous and you want to write it down just in case you forget stuff. But there's this triangle. These are called formula triangles. Again, I don't like them too much, but if you feel they help you, you can use them. So this is one of the triangles here. And what we do is we draw some divisions. So we divide a triangle into half, a top half and bottom half, and then a left and right from the bottom part. And we put in some variables. So if I want to find the Let's go for our first equation here. We know that if you want to find the number of particles, you do number of moles times Na. So the vertical line represents a multiplication. The horizontal line would represent the division. So for example, let's say you want to find the number of moles, this here, it's simply going to be N over Na. You can see that meets the formula there. Let's say instead you want to find the number of particles, you would do little n times Na, because the vertical line is a multiplication. So in our legend here, vertical is a multiplication and horizontal is a division. And so you have all your formulas within that triangle. You could do a similar triangle for the other equation with mass. So for example, if you want to find mass, you know that's moles times molar mass. That's a big M there. And if you want to find moles, so let's say you want to find moles, that's mass over molar mass. If you want to find mass, that's moles times molar mass. And so you can use those triangles to help you to remember the formulas. It's best to probably just remember these two formulas and then derive them, and then you know how to work backwards and forwards from particles to mass. Lastly, if you want to find the number of atoms, so just a recap, so let's say you want to find number of atoms from a molecule or other compound. So what you do there is it's not so much a formula, it's more a conversion factor. You simply do your number of particles multiplied by the number of atoms in one of those particles, or one of those compounds. So for example, if you want to find how many waters there are, or how many H's there are in 180 molecules of H2O, you're going to do 180 molecules times 2 atoms of H per water particle. So you basically are just multiplying your number of molecules or particles by your number of atoms that you're interested in. If it's all the atoms, you count all the atoms up. If it's just one of the types of atoms, you count those up, and that's about it. And likewise, if you want to go backwards, so suppose you had the number of atoms and you want to find the number of particles from there, you would just do your number of number of atoms that you have that's there, and then afterwards divide that by the number of atoms in one of the particles. So if you had the number of atoms total, so let's say you had total number of atoms, and you want to find the number of particles, you would have to multiply that by one particle over the number of atoms present in the compound. So examples here, let's say we had 180 water molecules, and I asked you how many H atoms are there. You would do 180 water molecules times 2 H atoms per H2O. Cross that out, you get 36H. If, on the other hand, I said, not 36H, 360H. If, on the other hand, I said you have 360H, how many H2Os you would do 360H times in one H2O, there's two H atoms. So you cross that H, you're doing 360 times 1 divided by 2. That's 180 H2O. So that was another problem. Remember that if you're asked to do that, let's say you have the mass, you'd have to go to moles first, then the particles, then multiply by the number of atoms. Or if you want to find the mass from the number of atoms, you'd have to find the number of particles first. So divide by the number of atoms present in one particle, and then go to moles, and then go to mass. So you'd have to, again, make your way to one of these directions here to find your overall answer.